Assalamu alaikum and hello everyone here. My name is Hamna Saleem and my education background is environmental biotechnology. I am working right now as a research assistant in Indigenous-led environmental monitoring program at Northern Alberta Institute of Technology in Edmonton. Today I will be talking about enhancing treatment wetland resilience, the traditional role of traditional ecological knowledge alongside Western science. So in this presentation, I will be talking about case studies from Pakistan, Canada, and technical protocols for scalable solutions. The work was led by my husband, Dr. Mohammed Arslan, alongside with his wonderful colleagues in Pakistan, Canada, and Germany. The collaborations bring together traditional indigenous knowledge and modern science to solve water challenges. These presentations reflects years of research focused on empowering communities, especially in Pakistan, through floating treatment wetland. Our goal today is to show how traditional ecological knowledge needed when we need to solve environmental challenges. When many people hear the word traditional and think it means outdated, but traditional ecological knowledge or tech is anything but it adapt with nature. It's practical and it helps create meaningful environmental solutions. Tech is about understanding the land from years of direct experience passed through generations. It includes farming, building, planting, and water care. Tech is not in competition with science. It completes the picture science sometime miss. Okay, let me start with a few eye-opening facts. Since 1700s, we have lost about 87 of the world's wetlands. That's like draining the plant kidney. Today, 2.2 billion people, including many in rural or indigenous communities, still lack access to safe drinking water. Meanwhile, 80% of the wastewater worldwide is never treated before being released back into the nature. These are urgent issues, but they are not without solutions. Our wetlands are disappearing, and globally, 2.2 billion people, that's almost 1 in 4 still do not have access to safe drinking water. Wetland helps solve this, but we need to act fast. Uh, Without wetland, we lose nature's way of filtering water. We also increase flood risk and loss wildfire. Um, this crisis affect communities across the world, which is why low-cost, community-driven wetland systems are so important here. Traditional ecological knowledge or tech is built through generations of deep observations and interactions with environment. When combined with scientific knowledge and data, it becomes a powerful approach to managing natural resources. Sustainability. Think of tech as a living library of environmental knowledge built by experience, not just textbooks. Tech doesn't replace science, it fills in the gap that numbers alone cannot explain. This energy creates smarter, more culturally respectful solutions. It seems like my computer is slow today. That's okay. Indigenous communities protect much of our world's biodiversity, yet they often have the least access to clean, safe water. This is especially true in remote areas where infrastructure is hard to build. We must include indigenous voices and tech in designing solutions like treatment wetlands. This is not just an ecological issue, this is an issue of equity as well. By involving local knowledge holder, we honor their stewardship and of land and also co-create better system that are more effective and better maintained. When tech is integrated into treatment wetland design, the result is not only better environmental performance, but also strong community connection. People care for what they help to create. This sense of ownership is what makes the difference between a project that lasts 1 year and one that thrives for a decade. Local people understand the climate, the plants, and the land. Including them make the solution resilient and long lasting as well. Let's look at some real world examples. Picture on the bottom right. In Myanmar and Canada, indigenous led projects excuse me, brought life back to wetland. Their leadership shaped how and where the wetland were restored. These projects shows that tech isn't theoretical, it's practical. Site selection, plant choice, even construction method were informed by generations of knowledge. That's what made the project more successful. Okay, so here is the schematic flow for each step that needed to integrate a tech science plan. First needed step is to assessment. We need to identify local need and ecological conditions of the area. Second step is to co-design to engage local communities. Then implementation requires to engage local stakeholder in construction and planting. After that, we go for material selection and modular selection for to prioritize locally available resources first and then adapt tech techniques. In the last step, we go for adaptive monitoring, in which we look for combined microbial analysis and traditional indicator. For example, bird return. If birds are back, that's mean the wetland is restored. This framework come with multiple benefits. For example, it's natural, so less energy consumption. It connects different ethnic group of people together with training and educational benefits. It has long-term stability and it also engages stakeholders as well. So there are some other examples in the US. The Alba River restorations was one of the largest dam removal project, and it was successful because of the partnership with the Lower Alba tribe. In Australia, indigenous rangers used tech to maintain invasive paragrass. Both projects show that when indigenous leadership and local communities are front and center, restorations become more meaningful and effective. Tech guided decisions not just during planning, but throughout monitoring and care as well. Okay, in Alberta and East Trinity, Australia, floating wetland and acidic soil were managed with both science and indigenous knowledge. Over time, these wetlands improved not just because of the design, but because of the community involvement. Ecological restoration is not one week work. It needs time, care, and feedback. These case studies shows that local communities' involvement improve wetland not just initially, but years after years. Let's now focus on Pakistan. Excuse me. The need there is urgent. Most industrial waste is untreated and polluted water is used on farmland. This is why my husband, Dr. Arslan, and his team from NIPG Faisalabad created and deployed 22 floating treatment wetlands across the country. First picture shows agriculture pollutant pose a major threat to the surface water, farms, and the health of the people in Sindh. Second picture shows, sorry, okay. Yes, so in this picture, in here, first pictures, it shows agriculture pollutant pose a major threat to the surface water, farms, and health of the people in Sindh. And the second picture shows drinking water contaminated in Karachi. Um And the picture C shows here pollution in an industrial area of Karachi. And the last picture in D, it shows untreated effluent flowing in a water drain in Faisalabad. Okay, talking about design, scale, and impact, co-design use beautiful mix of traditional knowledge and modern design. For example, bamboo frames, local clay, and plant like vetiver and typha are combined with polyethylene rafts and microbial technology. They are effective and affordable, up to 500 times cheaper than conventional system. In Pakistan, 22 sites treating 60% sewage and 40% industrial waste. So your first picture here, it shows ancient bamboo rafts have returned to Baltistan as dozens of young people paddled in this river to promote winter sports and tourism in the northern Pakistan region. And second picture it shows a woman named Devi and her two sons standing outside their homes. This is what makes the project scalable. Communities don't need high cost equipment or chemicals. They use what's available, material they know and trust, along with engineering methods to make them work in a new ways. That's sustainability in action. Here you can see the technical structure. The rafts are made from polyethylene sheets with bamboo frames, specialized with PVC and anchored with gravel. Traditional chikni matti or clay is used just like it is used in rural constructions. In plant selections, native macrophytes were chosen because of their high metal intake. Vetiver absorbs heavy metals in industrial wastewater. This integration method, because people understand and trust these materials, using familiar with things makes it easier to explain, replicate, and maintain the system. Plus, it reduces cost and connects to the solutions culture as well. Okay, so Dr. Arslan and his colleagues in NIPG, they published their protocol to establish low-cost floating treatment wetlands at large scale in a reputed journal. And I'm going to explain all the key steps from the STAR protocols that the team has created. It is standard method to build and install these systems. It shows systematic flow of design and how much time requires. It also covers everything: water depth, plant choice, material, and how to anchor it. When coconut shaving are used, even coconut shavings are used to prevent soil loss. Okay, so the first step is a nursery setup. Growing local macrophytes takes 3 to 4 months. Here are some pictures. Taking seedlings from wastewater exposed site and then grow them in a plastic pot with the coconut shaving to prevent soil loss, and then acclimate plants to ambient site conditions. Here are some pictures shown here setting up nursery. After nursery setup, comes with a raft construction. Polyethylene sheet, there's measurements as well, has been used with bamboo frame. It's traditional waterborne structure. Um, to assemble, cut sheet into rafts, uh, weatherproof edges with aluminium foil, and drill 14 holes raft per raft is like 12.5 centimeter of diameter for plant pots, and then insert PVC pipes to protect anchoring wires. You can also see in the picture here. Okay, in the vegetation step, insert pre-grown nursery pots into the raft hole. Use loamy soil, 8%, that is 8% sand, 43% silt, and 19% clay, plus gravel, 4 to 64 millimeter pebbles to shield roots from UV or heat. Traditional knowledge integration here is to use 2.5 centimeter soil layer with chickpea matti, That's a clay soil traditionally used for mud walls and secure plants with 5 gram per pot coconut shaving to control soil erosion control. Did these floating treatment wetlands withstood the 2022 flooding in any area? Could be mentioned if these were installed in same flood-prone areas. In the last step is island assembly, in which all the rafts has secure and 60 kg concrete anchors for 4 per island and use of bamboo straps and metal wires for stability. 455 rafts is almost equal to 1,000 meter square coverage. That is 20 to 33% of pond area. Uh, okay, monitor buoyancy during monsoon is required and adjust wire length to historical flood levels. These systems are designed to last, not just survive, but perform years after years. This gives communities the confidence to rely on them and invest time into maintenance and care. These pictures from one of the site in Pakistan shows full-scale floating treatment wetland proficiently installed on a waste stabilization pond. It maintained integrity even after 9 years of operation. Okay, so talking about protocol adaptability, adjust plant species for local pollutants. For example, Uncas for heavy metals, modify raft size or shape for different water bodies and different type of wastewater. Uh, avoid non-native invasive species. Consult elders for tech-aligned design tweaks. One key strength is flexibility here. These wetlands can be adjusted for different environment, whether that's in a pond, lake, or lagoon. You can change the anchor length, supplement nutrient, and prune plants are needed as needed. Um, this means the STAR protocol isn't limited to one region of a country. It's adaptability, which is exactly what we need for changing climate and diverse communities. In Canada, Indigenous knowledge is an important part of our governmental policies. Pakistan need this shift as well. In conclusion, I would say that every community is different, so there is no one size fit all. But we can build system that respect local priorities and adapt over time. We need more tech science workshops, better policies, and new tools like Green Bond to fund them. Uh, this slide is a call to action as well. The future of water management must be community based, culturally grounded, and backed by supportive funding and government structures. Um, at the end, I want to deeply acknowledge Dr. Arslan and his research partners. And also, I express my sincere gratitude to Hoopo and Dr. Nasir Saab, who offered me this platform. Their vision, especially the community work and continues to strengthen trust, resilience at the local level. These projects wouldn't be possible without both the researchers and community leaders who make this work real on the ground. And thank you so much for your attention.